Alright, let's look at the homework 3.2, problem number 10. Alright, so we want to find the equations of the tangent lines to the curve y equals x minus 1 over x plus 1 that are parallel to the line x minus 2y equals 5. Alright, so since we're talking about the tangent lines, we need two pieces of information. One is the slope and the other one is a point. Right, so the slope is easy to find because since tangent lines are parallel to this line, so if I rewrite this equation here, let's solve for y. So I'm going to subtract x from both sides. So we have 2y is equal to negative x plus 5. Right, then we can just divide through by negative 2 so that we can get rid of this negative 2 here. So it's y is equal to negative x divided by negative 2, it would be 1/2 x, negative negative positive. Right, then you have a minus 5 halves. Right, so you can see that the slope shows up right here. Alright, so the slope is going to be 1/2. Alright, then we can talk about the slope of the tangent line by finding its derivative too. So we're going to take the derivative, right, using the quotient rule. Right, square the bottom, x plus 1 squared. Right, derivative of the top is 1 times the bottom, which is x plus 1, minus top, which is x minus 1, times the derivative of the bottom, which is 1. Right, then if you simplify that, you can see that there's a x minus x is there. So 1 minus negative 1 would be 2. So this is just going to be 2 over x plus 1 squared. Alright, then we want to find the x value, which makes this derivative equal to 1/2, since the slope is equal to 1/2. So I'm going to set this guy equal to 1/2. Alright, and first step would be I'm going to take the reciprocal of both sides. Alright, so put everyone upside down. So it's x plus 1 squared over 2 is equal to 2. Right? Then multiply both sides by 2. So we have x plus 1 squared is equal to 4. Right? Then I'm going to go down here. Right? Next step would be taking a square root. Then we have x plus 1 is equal to square root of 4 is 2, but we have to consider plus or minus 2. Right, then we can just subtract 1. So x is equal to either 2 minus 1 would be 1. Right, negative 2 minus 1 is negative 3. Right, so we have that. So at those points, slope becomes exactly equal to 1/2. Alright, so we just have to, so let's see, so we are looking at the two equations. So here, tangent line 1, let's see, tangent line number 1, right, we need a slope m, which is going to be 1/2, right, and point, so I'm going to call it the x1 comma y1 is going to be x is going to be 1, right? Then corresponding y value, you can just plug it in here. So if you plug 1 into the original function here, so it's going to be 1 minus 1 is 0 over 2, so it's going to be 0. So this is that. Right, so the information for tangent line number 2, it would be Alright, so slope is exactly the same because they both are parallel to the given line. And the point, so I'm going to call it x2 comma y2 so that I can I can distinguish this guy from that guy. And x value is -3, right? If you plug again -3 into the original function there, you're going to get the -4 over -2, so that will be 2. So we have that. Alright, then equation for this guy would be y minus y1, which is 0, and slope is 1/2. Then x minus x1, which is this guy. Alright, and we can simplify it. You can write it as 0 really doesn't do anything, so it's going to be y. Distribute 1/2, so it's a 1/2 x minus 1/2. Alright, for this guy, same way, y minus y2, which is 2, is equal to, slope is 1/2, x minus -3, so that will be plus 3. Alright, so if you want, we can write it as a 1/2 x plus 3 over 2. Then I can just add 2 to both sides to get y equals 1/2 x plus 2 is 4 halves, so it's going to be 7 halves. Alright, so let's type this guy in. Alright, so we have alright, so we got let's see, y equals 1/2 x minus 1/2, and the other one is 1/2 x plus 7 halves. Alright, so let's submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.